Hello everyone, so in this video we are going to calculate energy and power of a signal using MATLAB. So for this we are going to use a function which is equal to xn is equals to n, where n is varying from -2 to 2. So what we will do using MATLAB, we'll plot this function, then we'll calculate the energy, and then we will calculate the power of the signal. So first we will mathematically calculate energy and power of a signal using the formula which I have already explained in my previous video. So we know that in order to calculate the energy of the signal, we will use minus n to n summation mod of xn whole square. So here our interval is varying from -2 to 2 and our xn is equals to n, so here we will get n square. So what this means, it is equals to -2 whole square plus -1 whole square plus 0 square plus 1 square plus 2 square, and the sum will come out to be 10. So the energy is basically equal to 10. Now in order to calculate the power, what we'll do, we'll use the energy and we will divide it with the time interval. So here the energy is 10 and time interval is 5, because here you can see that the n value is varying from -2 to 2, so it will be taking value -2, -1, 0, 1 and 2 in the set, so these will be equal to 5. So the value of power will comes out to be 2. So these are the mathematical calculation. So before going into the MATLAB code, I'll just explain you what different MATLAB functions we are going to use to calculate the energy and power of the signal. So as I've already written the formula for energy as -n to n summation mod of xn whole square. So here the operations which we are doing on our function xn are, first we are taking a mod which is basically absolute value. So the corresponding function in MATLAB is basically ABS. So if we'll do ABS of our function xn, this implies that it's a mod value of xn. Now next operation is squaring. So in order to square this absolute value of xn, we will use the function dot hat of 2. So there is usually a confusion among students about this dot operator. So why we use this operator? Because it implies element wise operation. So whenever we require some element wise operation, then we will use this dot. So suppose there is some variable x and it is taking some scalar value which is 4. So in order to calculate its square, we can directly use the hat operation x2, which will give you 16. But suppose x is a vector and it takes values 1, 2, 3, just for an example. So simple hat operation doesn't suffice and it will give error in MATLAB. So what we will do, we will do the element wise. So x dot hat of 2, what it will give, it will do element wise square. So it will square 1 square 1, then it will square 2, and then it will square 3. So the output result will be a vector which will contain 1, 4 and 9. So that's why whenever we have a vector, then we need this element wise operation. And as we know that our interval is varying from -2 to 2, so xn is basically a vector. So we, in order to calculate the square of that value, we have to do element wise square. So that's why this dot comes. So now the third and the last operation is summation, and for that, we'll just use sum function. So the final form of calculating the energy will be equal to E is equals to sum of ABS of Xn. So this will give you the energy. In order to calculate the power, we will divide our energy with the time interval, and for that we'll use the function length of n, and that will give us the power. Now let's code it in MATLAB. Energy and power. So as already discussed, we are going to use the function xn is equals to n, and we will take our interval varying from -2 to 2. So let's take the interval n is equals to -2 to 2. So it will take value from -2 to 2 with one time step, which is -2, -1, 0, 1 and 2. So next we will define our function, which is xn is equals to n. So it will get the same value as n. Now before calculating the energy and power of the signal, let's plot and see how this function looks like. So we'll do stem of xn. So I've already explained in my previous video that in order to plot a discrete time signal, you have to use stem function. So here it's just a revision of that concept. So we'll see stem of xn. So it will show us a discrete time plot, and here you can see it is taking value from -2 to 2. Now I have already discussed all the functions which is required to calculate the energy of the signal. We'll just have to apply here. So energy E is equals to, first we have to take the absolute value of our function, so we will use abs function. So ABS of x of n will give you the absolute value, and now we have to square it, and I've already explained here we have to use the element wise square. So we'll do the dot operation and then hat of 2. Next we have to use the summation. So we use the sum function to sum it over the interval -2 to 2. So this will give you the energy. So let's calculate, and here you can see energy is equal to 10, which basically matches with our mathematical calculation. So next we'll calculate the power, and we all know that power is basically energy divided by the time interval. So in order to calculate the time interval of a variable, we'll use the function length, and the variable here is n. So it will give value 5, which is quite visible from this also, that it's varying from -2 to 2. So it is taking 5 values, -2, -1, 0, 1, 2. So length n will give you 5. So here you'll get P as 2. So this was a short implementation of what we have studied about energy and power of a signal. Thank you.